The answer is yes. Does anyone know why all three of those angles are the same measure?
All the arcs are the same.
Very good. Which arc do they all form, Zach?
PQ.
Excellent, Cody. Thank you, Zach. Okay. The arc PQ is formed by all three of those angles. Therefore, all three of the angles must be the same measure. Okay. You could have, in your explanation, either name dropped that theorem, which was the inscribed angles in a circle theorem, or you could have said, yes, they all form the arc PQ. Okay? Danny, were you going to ask me about that theorem?
I was going to say that, is it okay if I also put that theorem?
Yes, absolutely. Okay. So remember, guys, when you're explaining, you can either describe like exactly what's happening. Like if you put they all form the arc PQ, full credit. If you name drop the theorem that proves that this is true, which is the inscribed angles in a circle theorem, you get full credit. Okay. It's if you don't put any explanation or your explanation is wrong, that's where we start to dock points. Okay. What questions do we have on this warm up? Okay, cool beans. Guys, take out your 8.4, or no, 8.4. I keep doing that. 10.4, your big ideas. I want to go over the homework, please. We're talking about angle relationships in circles now, but so what we've seen before is I want you to draw a circle just so you can visualize like how this lesson is different than the previous ones. We've seen where angles stemmed from the center. Does anyone remember what we would call angles like this? Central angles. Very good, Val. Okay. Then we also saw angles that were like from the edge of the circle. What were these angles called? Inscribed angles. Okay. In center. That was back when we were talking about triangles, bro. Okay. So this is an inscribed angle. Today what we're looking at is angles that are inside and outside the circle that are not in the center. Okay. So we're going to see angles that are stemming from like right here. And we're going to see angles that are inside the circle, but not necessarily in the center. Okay. So why is this important? It's important because we cannot use our previous knowledge to find these angles. Okay. There are new formulas that we're going to have to memorize in order to locate these or to figure out the measure of each of these angles. Okay. All right. And the first one that we're going to start with is something that happens when we have a tangent and an intersected chord. Okay? If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. Okay? So if you look at that figure, the red arc corresponds to the angle of angle 1. And the blue arc corresponds to the angle 2. So we're going to do, how I like to explain this problem is I like to actually give them values. So I'd like you to draw where the blue arc is 200 degrees. So fill in that angle or that arc is 200 degrees. If that arc is 200 degrees, what would be the measure of the angle 2? It would be 100 degrees. Why? It's going to be half of the arc. Very good. Okay. Now from here, if we know that this angle, angle 2, is 100 degrees, what would angle 1 have to be? 80. Why? Why do 2 and 1 have to add up to 180? Think more simple than that. Yeah?
Well, because the whole circle is 360, the red arc is going to be 160.
More simple than that. What is the relationship between angle 2 and angle 1? They're not vertical. Yeah?
Why would you intersect when it's like on the same line?
What do we call that? Adjacent. What else do we call it when it's specific like this?
Supplementary.
Starts with an L. Linear pair. Okay? So remember, these two angles are going to be linear pairs. So if this one's 100, this one has to be 80. Okay? And if that one's 80, how do we find the measure of the arc if we know the angle? You multiply by 2. So this one would be 160 degrees. Now always check. What were all the arcs in a circle supposed to add up to? Do 200 and 160 add up to 360?
Yes.
boom, we're good, okay? So just remember, when you're talking about the angles, it's gonna be half, right? They're gonna add up to 180. Exactly double 180 when you're talking about the circle is gonna add up to 360. What would happen if AB was a diameter? What would angle 1 and angle 2 be in this case? If AB was a diameter, Juan? Yes. What would be the measure of angle 1 and angle 2 if AB was a diameter? Yeah? Excellent. They would both be 90 degrees. Do you know why? Very good. Because if it's a diameter, right, then each of the arcs would be how much? 180. Divide 180 by 2, you get 90 degrees each. Remember, that's also the definition of a tangent line. If a tangent line touches a circle, it's going to make a perpendicular line with the radius, okay? All right, moving on. So let's go ahead and do some examples. These are going to take like 5 seconds. What would the measure of angle 1 be? Why? Very good. You're taking 210, you're dividing it by 2. The measure of angle 1 would be 105 degrees. Excellent. What about RST, the arc? What? Hayden? What did you say? 186? It's close. I think you had the right idea. It's 196. Why, Ronnie? Oh, you said 196? My bad. 196 is correct. How'd you get that, Hayden? Yeah, you just multiply by 2. That'll give you the measure of the arc. So 196. Make sure you have a degree symbol there. That's very important. All right, and the measure of XY. 160. How'd you get that, Nick? Excellent. Okay. It is 80 times 2. What questions do we have on 1, 2, or 3? Okay, moving on. All right, so this is where we talk about where those intersecting lines, the angles, can either be inside, outside, or on the circle. Guys, we've already touched on the circle one. So circle these two. These are the two that we're looking at today, where the point is inside the circle. It's not necessarily going to be in the center, though, and where the point is outside the circle, where the angle is stemming from outside the circle. Okay, so we're going to start by looking at the angle when it's inside the circle. So this happens when two chords intersect inside of a circle. Then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle, okay? So basically you're going to, when you have two chords that intersect, you're gonna get two arcs that are created, okay? Normally one's gonna be a larger arc and one's gonna be a smaller arc, okay? In this case, if we're looking at for angle 1, the two arcs that are created are DC and AB. How we figure out the measure of angle 1 is we add those two arcs together and then we divide it by 2. We use that same logic if you want to find angle 3. Because why would angle 1 and angle 3 be the same? Zach? They're vertical angles. Very good. So if you find one of them, you found the other. So the formula for finding either of them is the same. You're adding DC and AB, and you're dividing it by 2. Now, if you wanted to find angle 2 or angle 4, what two arcs would you have to add together, Christian? AD and BC, okay? And then you would divide that value by 2, okay? Now, 2 and 4 are going to be vertical as well, so they should be congruent. What questions do we have on this slide? Okay. Now, when the angle is outside of the circle, okay, it can be, there are a bunch of different scenarios that could happen. You could have two lines that are secants. In other words, that first example, both of those lines are secants because they intersect the circle twice. You could have two lines that are tangents, that are both tangents. That's the second example that we're looking at. Or you could have an example where one is a tangent and one is a secant, okay? The cool part is for you guys is you only have to remember one formula, okay? And that's x minus y divided by 2. But x and y cannot be interchanged. X will always represent, and you definitely want to write this down, the larger arc. And Y will always represent the smaller arc. Okay? Now, this formula is easier than it seems because you're going to know that angle for the measure of angle 1 should never be negative. So you never want to put the smaller arc minus the larger arc, right? Because if your arcs were 80 and 40, what would you get if you did 40 minus 80? Negative 40, right? So you always want to put the larger arc first, okay? Because that will always be, you always want to keep a positive value for your angle, okay? So just remember the large arc minus the small arc, and then we're still dividing it by 2, okay? All right, moving on. God bless you. Okay, now that middle example where both of the sides were tangent, that's something that we're going to call a circumscribed angle. A circumscribed angle is an angle whose sides are tangent to the circle. So both of the sides are going to be tangent, okay? Excuse me. And then the last theorem that we're learning today is the circumscribed angle theorem. All that theorem says is that if you have a circumscribed angle, okay, the measure of the angle is equal to 180 minus the measure of the central angle that intercepts the same arc. And we're actually going to walk through how to prove this theorem. So which of these angles in the figure is the central angle and why? Which of these angles is the central angle and why? Juliet? Very good. It's ACB because it stems from the center of the circle. Very good, okay? So what this theorem says is that this angle, you could figure out angle D by taking 180, subtracting the angle at point C, okay? Let's go ahead and prove it. I want you guys to, we're going to prove this by outlining the figure that's shown here. So this is the figure that we get. What do we call that kind of figure?
Cone.
It's a kite, okay? But more basic than, yeah, it is a polygon, more specific than a polygon. It's a quadrilateral, very good. So let's go ahead and write that down. It's a quadrilateral. And what do we know about the angles inside of a quadrilateral? It is a kite. But what do we know about the angles inside of a quadrilateral? What do we know about the angles inside of a quadrilateral? Thank you. They add to 360 degrees. Do we know anything else about these angles inside this specific quadrilateral? AD is tangent, correct? What angles do tangents make with the radius? So do you guys agree this has to be a 90-degree angle? What else would have to be a 90-degree angle? Angle CBD. So if two of my angles are 90 and I have 360 degrees to deal with, what do I know about C and D? Let me rephrase that. If all of my angles add up to 360, I know that two of my angles are 90. What do I know about the last two? They must add up to 180. They must be supplementary. So the measure of angle D plus the measure of angle C equals 180, okay? We just proved the theorem that we were talking about, okay? Because the fact that any tangent is going to be perpendicular to the radius, that forms two 90-degree angles at A and B. Therefore, C and D must add up to 180 degrees. What questions do we have on this example? Cute. Let's move on. And I think we got to the examples. Cool. So we're just doing examples, guys. That's all the new knowledge that you need to know. Now let's go ahead and try to apply it to some examples. So UT is tangent to the circle. So that's, if we were to extend it, it would only hit the circle at one point. It's very hard to see, okay? Did not print well. And then we want to find the measure of the arc, WT. So here's the other side of the angle U. We want to find the measure of the arc, WT. Now, first things first, guys, is the angle U, is it inside or outside the circle? Outside. It's outside, so we're going to use that formula, big arc minus small arc, okay? So we're going to set up the measure of the angle U is going to be the large arc. Which of those two is the large arc? Don't say the degrees, say the actual name of the arc. ST, very good. So it's going to be the measure of the arc ST minus, what's the small arc in this figure? Not UT. UT is a segment. TU, still a segment. It would be WT. Why would it be WT, guys? Yeah, because it's a small arc and both of those points are on the circle. Do you guys agree? So it'd be minus the measure of the arc WT. What do we have to do with the arcs, though? This is not the correct formula. Over 2, okay? We have to divide by 2. Okay, so this is our formula for finding out the measure of angle U. Now let's go ahead and plug in what we know. Do we know the measure of angle U? Yes. How much is it? 30. So let's substitute that in there. So 30 is going to be equal to the measure of, do we know ST? Very good. It is 100 degrees. Do we know what WT is? No, that's the one that we're missing. That smaller arc. Let's make it X. Let's make it a variable, and we're still dividing by 2. Guys, who can tell me what they would do to solve for X here? Juan? What's that? Multiply by 2. Very good on both sides. Because that will get rid of that 2 in the denominator. And now I've got X with no denominator. So multiply both sides by 2. You're going to get 60 equals 100 minus X. What do I do after that? Good, Diana. Subtract 100 from both sides. What's 60 minus 100? Negative 40 equals negative X. So X is going to be 40 degrees. Guys, I just found my missing arc. So that arc, WT, is 40 degrees. What questions do we have on the first example of getting 40 degrees? Yeah, go ahead, Hannah.
Now, if it's, if you have the other three, if you were to try to find arc RS, could you just add them all up and subtract them?
Very good. Did you guys hear what Hannah said? At this point, we know all of the arcs except for RS, so we can add all of them up and subtract from 360, okay? We'll get there, though, okay? Yes?
But isn't it
Isn't what a vertical angle? Yes, but remember, Christian, these two would only make the arcs congruent if they were central angles. This is not in the center, do you agree? So they're going to be different arcs, okay? And you can tell RS is pretty bigger, much bigger than WT, do you agree? So let's be careful about that, okay? All right, TVS, guys. TVS is that angle on the bottom there. This one, right? How do we find an angle inside of a circle? Hayden? Divide the arc by 2. That's if that point was on the edge of the circle. We just learned a new formula for finding the measure of an angle inside of a circle. And it's not big minus small divided by 2. Cody? We are eventually going to divide by 2. But this one, we don't take the 100 and divide it by 2 because that only happens when our vertex is on the edge of the circle. In this case, where's our vertex? It's inside the circle, right? But not in the middle. So what do I do?
Is it 100 plus 110 divided by 2?
There she is, okay? It's going to be 100 plus 110 divided by 2. Remember, when you have an angle that is inside of your circle, you have to add up both the arcs that are created, which are the 110 and the 100, and divide that by 2. So we're going to say the measure of the angle TVS equals 100 plus 110 divided by 2. This is going to give me 210 divided by 2, which is 105 degrees. Go ahead, Hannah.
I'm confused on why we can't still just do the like 100 going to TBS and it's like 50 degrees, but what's like the visual difference between this and yesterday?
Yeah. So that would only happen if your vertex was on the edge of the circle, like this, that blue angle, okay? So this changes everything when that vertex, right, is somewhere inside the circle. Got it? You see the difference now?
Yeah.
Okay. What other questions do we have on the blue example? Okay, what if we were asked to find RVS? There's an easy way and there's a hard way. I would like us to only do the easy way. Dougie?
They have 110, 140, so just add them together, right?
The 110 over here and the 40?
The 110, the 40, and the 100. So
And the 100?
you add them together, and then you do 360 minus.
That's the hard way.
That's the hard one?
That's the hard way. Hannah?
Are WVT and RVS vertical angles?
They are.
So could you like use them?
That would also be a hard way. What do you notice about the green angle and the blue angle? Yeah? They're a linear pair. What can we do with the 105 to figure out the other angle? Subtract it from 180. We do 180 minus 105. This is the easy way, and we get 75. That's the measure of this angle. Do you guys agree that was a bit easier than figuring out the arc, than adding the two arcs, dividing it by 2? Okay? So that angle must be 75 degrees. Now, when we're finding RS, the arc, this is where we're going to have to do what Hannah was talking about, which was add up all of the arcs that we already know and subtract them from 360. So we knew the 40, we knew the 110, and we knew the 100. Let's do 360 minus 110, minus 40, and minus 100. And we should get 110 degrees. And that's the measure of RS. Can someone check my math on that one, please? With their calculator? Kristen? Yes, please. All right, move on. Example 2. They get easier from here. That was the most complicated example we'll do, okay? What if the measure of the arc AB was 105? Let's fill that in there. That's 105 degrees. What would be the measure of the angle D? Guys, is D inside, outside, or on the circle? Outside. What formula are we going to use? What's the formula for an angle that's outside? X minus y divided by 2, where x is the big, right? And y is the small. So do you guys agree this would be the big arc? And this would be the small arc? Okay? Sometimes it helps to draw your dots so you can see where the arcs are ending and beginning. What is the measure of that big arc?
180.
It's not 180. It's going to be more than 180.
But it's not contemporary.
Sometimes it helps to draw colors so you can visually see how big that big arc is and how big that small arc is. 255. Who said 255? Why is it 255?
Because
Grayson, please go.
180 minus 105 is 75, and then 180 plus 75 is
Very good. This arc had to be 75. This one had to be 180. Adding 180 and 75 gives me 255. Any other ideas on how to get there? There's one other way to get there. Yeah? Isabella? Very good. You could have just done 360 minus the 105 that we already had. So now that we have both of our arcs, okay, what do I do with them?
You're gonna do 255.
So the measure of angle D is going to be, you said 255. Why do we start with that one? It's the bigger one. Minus 105. And then what? Divide by 2. So the measure of angle D is going to be, I think this is 150 over 2, which is 75 degrees. That's it. Not so bad, right? Yes. What? Why do you think we're doing it in the notes? Yes. Divide by 2. Wait, if you're finding the arc, no, you're right. You multiply by 2. Okay? All right, let's check out a previous example, Cody. What's 105 times 2? 210. Was this arc 210? It does not work like that every time, okay? Do not think that that is a pattern that I did 360 minus the 105, okay? And I got 255. Good question. What other questions do we have? Cody, you gave me a look. Are you sure you're okay with that last example? One. Let's get in example 3, we have the angle. We're given the angle. We're given one of the arcs, but we're missing this last arc. Let's make it X for us, okay? We're missing AB. When we're setting up the equation now, be careful because you know the measure of the angle now. Who thinks they know how to set up the equation for this one? Nick? Very good. Okay. 1/2 times x minus 20 equals 10. When I did this problem, I wrote it a little bit different, but you're absolutely correct. I wrote it as 10 equals x minus 20 over 2. Okay. But both of them are the same. Okay. So when I write it like this, guys, I'm saying the measure of the angle, which is 10 degrees, is equal to the big arc, which was x, minus the small arc, which was 20, divided by 2. What do I do to solve for x here?
Multiply 2.
Excellent, Zach. Multiply both sides by 2. So we're going to get 20 equals x minus 20 because the 2's will cancel. Now we just add 20 to both sides. What's x equal to? X equals 40. No. Okay? I know a lot of students, they're like, oh, if that one's 20, then the other one has to be 40 because you just multiply it by 2. Big no-no, okay? Do not just take this smaller arc and multiply it by 2. That is a big, big no-no, okay? Look and rely on, okay? Zach, can you explain it? All right, example 4, find the value of x. We're given a central angle. We're given that angle of angle D is going to be x. Who remembers this is a theorem all in itself. What do we do with these two values? Hannah? Very good. They're supplementary, okay? So we're going to say x plus 135 equals 180. Subtract 135 minus 135. You're going to get that x is equal to 45 degrees. Because remember, this is a kite, and both of these angles must be 90 degrees. Cool beans. What questions do we have on any of those examples?
How are they supplementary?
What?
How are they supplementary?
So that was a theorem all in itself. It said if you have an exterior angle where it forms two tangents, right? Do you agree that A and B are points of tangency? Then the two angles, the central angle and that angle on the outside, have to be supplements of one another. Yeah, Sophia. Away. Christian, you wanted this one?
Yeah.
Okay. Do not turn these in until you answer that exit ticket, okay? It's a point of significance for you. I need you to tell me what was the most significant point of this lesson. When did a light bulb go off? When were you like, I think I get it now, okay? Like, what? Then what was the point that you didn't understand, right? Or what's the concept that is most significant because you definitely need to study it, right? It could work in that way. What's going to be the most, or the concept that will definitely help you the most if you understand it?